Hi, I'm Wendy Zukerman and you're listening to Science Versus from Gimlet Media. On today's show, we're pitting facts against fake sugar as we tackle artificial sweeteners. And we heard from a lot of you with thoughts on our nuclear power episode. Thank you so much for your comments, and please stick around for a few quick clarifications and corrections at the end of the episode. Okay, but first, on to sweeter things. Artificial sweeteners. So, artificial sweeteners are no-calorie or low-calorie sweeteners that flavour, among other things, diet sodas. And because they're low-cal, no-cal, so-cal, for decades, advertisers have been licking their lips and promising that these diet drinks will give us a healthier, happy-go-lucky life.
You hear it, taste it, it's right.
You just heard Whitney Houston, Elton John and Ray Charles sing the praises of diet sodas. Literally. And artificial sweeteners aren't just in drinks. They're in chewing gum, frozen dinners, vitamins, toothpaste, mouthwash, bread, granola bars, yogurt, ice cream and medications. They're used so widely that one study said, quote, many individuals do not even realise that they are consuming them, end quote. According to the CDC, 1 in every 5 Americans drink diet drinks on any given day. And one of those Americans, someone who is a very big fan of diet sodas, is PJ Vogt. He's a colleague of mine and one of the hosts of Gimlet Media's podcast, Reply All.
Uh-huh.
What did you just pull out of your pocket?
12 ounces of Diet Coke, 12 ounces of diet sweetener.
And PJ really likes his diet sodas.
I keep one in each side pocket, so I feel like a cowboy with 2 pistols.
He drinks around 6 to 10 cans a day.
Today, it is right now 3 o'clock, and this is number 5.
Okay.
6.
6.
I just remember that, 6.
How long you been doing that for?
Probably like 15 years.
Yeah.
I've been drinking an unusual and like remarkable, in the sense that people remark on it, amount of diet soda since at least college.
And why does he go for diet sodas rather than the regular stuff? It's pretty simple.
The thing that is great about artificial sweetener, like the real deep appeal of it, is it seems like a great bargain. It's like, okay, it doesn't quite taste like sugar, but it tastes a lot like sugar, and it has no downside.
Yeah, that's the promise of artificial sweeteners, that you get something for nothing, all the sweetness with none of the guilt or the pounds. But not everyone is a fan of these drinks. Some scientists are critical of them because they're finding that artificial sweeteners may not be so good for us, and in particular, that they may be making us fat. They're saying that the message that these are diet drinks are misleading. And we've been hearing about this a lot in the news.
Sipping on diet soda may cause your waistline to bubble over.
Instead of helping people lose weight, research suggests that diet sweeteners might promote obesity.
Diet Coke and Diet Pepsi and Mountain Dew, all of these beverages, it looks like they increase your hunger and your thirst, and then your waistline increases.
And then there's another fear about artificial sweeteners, that they cause cancer. According to one survey, 1 in 4 people believe this. And it's something that PJ thinks about every now and then.
Every once in a while, I will Google, does Diet Coke give you cancer or whatever?
So PJ and lots of people who guzzle these drinks want to know, are artificial sweeteners bad? And for PJ, he wants to know for himself, but also so he can shush his critics.
A lot of those people, like, smoke cigarettes, or like a lot of those people have their own unhealthy habits that just like aren't as prominent. And so if I have one more piece of evidence, science has said this is fine, mind your business. That would be very great.
So let's dig into 2 big questions that have dogged artificial sweeteners for decades. 1, could artificial sweeteners cause cancer? And 2, are they making you fat? When it comes to artificial sweeteners, there are lots of ads showing beautiful people cracking open a cold one. But then there's science. Science versus artificial sweeteners is coming up just after the break. Welcome back. Today, we're digging into the science behind artificial sweeteners, and we're asking, are they dangerous? When we talk about artificial sweeteners, there's a whole family of products out there. But in this episode, we'll mainly talk about two different kinds. There's aspartame, that's sold as NutraSweet, and as Equal, which is found in those little blue packets. It's also been approved for use in over 6,000 products worldwide, and it's used in Diet Coke. So yeah, that's what PJ's been drinking. There's also saccharin, that's sold as Sweet and Low, and it comes in pink packets. And it's not just the colour of the packets that are different. Each artificial sweetener is a different chemical, which means that our bodies can deal with these chemicals in different ways. And a little bit of history on these products, because although they feel like a modern invention, they're actually quite old. So saccharin was the first artificial sweetener to be discovered, and it happened in 1879. Well, there's a couple of origin stories here, but one was that a chemist called Konstantin Fahlberg was experimenting with the byproducts of coal tar. That's the stuff that gets slathered on roads. And he came home one day and started eating some bread and realised that his hands tasted sweet. He later wrote, quote, "I ran back to the laboratory and tasted all the beakers, vials and dishes which stood on my work table, until I finally found the taste in the contents of one which seemed strikingly sweet." End quote. Boom. Saccharin was discovered. And another artificial sweetener, aspartame, was also discovered accidentally when a chemist licked his fingers in 1965. Over the next few decades, artificial sweeteners started flooding the market, and it was around this time when scientists started making a link between artificial sweeteners and cancer. Yes, the big C. And this takes us to our first question for today. Will eating and drinking artificial sweeteners give you cancer? To answer this question, we spoke to John Glendinning. He's a professor of biology who studies sweeteners at Barnard College in New York City. And he says that this fear of cancer, it was all around when he was growing up.
When I was a kid and you looked at a diet drink, they always use saccharin. And there's always a little disclaimer there that says, has been found to cause cancer in rats.
John says that these warnings had to be put on labels following research in the 1970s, which found that rats given saccharin had higher rates of bladder cancer than rats who didn't eat the stuff. But
it turns out that saccharin causes bladder cancer in male rats of one particular strain. Females didn't get it. If you looked at a different strain of rat, they didn't get it.
Still, scientists actually went looking for evidence that saccharin might increase our risk of bladder cancer. And what did they find? Well, according to the FDA, more than 30 studies in humans have shown that saccharin is safe for human consumption.
So you look at all the people that have been consuming saccharin, all the people that haven't, and there's no difference in bladder cancer rate.
So, saccharin seemed to be off the hook. And eventually, companies didn't have to display warnings about cancer in rats anymore. But then, fresh evidence came to light pinning cancer on a different artificial sweetener, aspartame. That's the stuff in Diet Coke. It pretty much all began in 1996 when a paper was published suggesting that aspartame might increase our risk of brain tumours.
The ingestion of the widely used artificial sweetener called aspartame, better known as NutraSweet or Equal, may just be responsible for what the authors say is a dramatic increase in the number of people who develop brain tumors.
At the time, researchers were noticing a spike in the rates of brain cancer in industrialised countries. And they noticed that spike came not long after aspartame was introduced into the US market in the early 1980s. So the scientists put 2 and 2 together, and they thought, I've got it. Aspartame might be causing the increase in brain tumours. The authors in this paper did not definitively say that aspartame caused brain cancer, but they said it might. In fact, this idea that aspartame causes brain tumours was so big in the mid-1990s that it made it all the way to rural Australia. What's that, Skip? You heard about brain tumours from diet soda too? Oh, yeah, so did our senior producer, Caitlin Sawrey. Anyway, she asked John about it.
Growing up in the 90s, I had this idea that artificial sweeteners would cause things like cancer, brain tumours. Has that held up over time?
No. So there's been a lot of work done on that. And there have been very detailed studies which have been conducted by the FDA, by the European Food Safety Organization, and all of them have largely debunked those claims.
A study on aspartame, which followed just under 500,000 people for 5 years, also concluded that the sweetener did not increase their risk of brain cancer. And a big review published in 2015, which looked at many different artificial sweeteners, so not just aspartame, also found that there was no conclusive evidence that they increased the risk of cancer. But the authors of that review did put a question mark over the risks of heavy, prolonged consumption when it came to artificial sweeteners. Given all that, John...
Oh, look at this.
Would you like a Coke?
Our biologist at Barnard says he doesn't mind cracking a can open every day.
I actually just had one. I have the Coke Zero.
Conclusion. Artificial sweeteners have not been conclusively found to cause cancer in humans. Okay, let's tackle our next question. Could artificial sweeteners be making us fat? It might seem crazy that something with 0 calories or practically 0 calories could make you put on weight. But that's something that some scientists are finding. Scientists like Susie Swithers. And yes, we know, her name sounds like a character from Charlie and the Chocolate Factory.
There is no life I know.
Here she is, Susie Swithers.
Okay, so in terms of comparing regular soda and diet soda, I think it's the wrong question. So I think
but if you had to answer that question.
So my answer to the question is don't drink soda every day.
Susie is a behavioural neuroscientist at Purdue University, and she's been researching the effects of artificial sweeteners on the body. And she says that, yeah, we've been sold a lie that these drinks are helping us to diet.
People who consumed the artificial sweeteners still ended up with increased risk for overweight and obesity and with increased risk of having a greater waist circumference.
But that does leave one very big question. How could drinking 0 calories make you fat?
Exactly. How could this be happening?
Well, Susie says that to understand that, we first need to know that a calorie is a measure of the energy that we get when our body breaks down food or drink. So, when we look at many artificial sweeteners, our bodies actually don't break them down to get energy, and so they're considered to have no calories. Now, aspartame actually can be broken down by our body and it can release a little bit of energy. So strictly speaking, it's not 0 calories. But because it's around 200 times sweeter than sugar and only a tiny amount of it needs to get added in a soda drink, the amount of calories that you get from drinking it are practically nothing. But still, it's thought that most artificial sweeteners don't get metabolized and so we don't get energy from them.
These sweeteners that were supposed to not do anything, we consume them, they don't have any calories, they don't have any energy, and then they pass out of our bodies. They're actually doing a lot of things after we consume them.
Susie started thinking this because of these counterintuitive results that she was getting in her studies in rats. And this was the thing that made a lot of headlines. So here's what she did. There were a series of experiments where she gave one group of rats yogurt sweetened with regular sugar. And then she got another group of rats and gave them yogurt sweetened with saccharin. And critically, all the rats in her study were also fed some sugar that went along with their yogurt. And she found that the rats who got the saccharin as well as the sugar gained more weight over the course of the study than the completely sugared up rats. Yeah, it's pretty surprising. The artificial sweetener-fed rats gained more weight, even though they were eating less calories.
Animals that have had the artificial sweeteners, they ended up eating more of the food they were allowed to eat.
And when she saw that, she was like,
wait a minute, this can't actually be happening. We're sort of triple checking everything. Did we do something stupid? Are our formulas messed up? And it really wasn't until we had seen these similar outcomes occur over and over again that I started to go, okay, you know what? This might actually be real.
Susie tells us that a couple of things might be going on here. But one is that when you eat sweet food, the tongue sends a message to the brain, which sends a message to the body that says, sweet food coming. And that triggers the release of chemicals in your stomach so that you get ready to digest the energy that's coming your way. But Susie says that if you're getting a diet that's sometimes sweetened up with fake sugar and sometimes sweetened up with real sugar, then maybe the brain starts to get the message, wait, are calories coming or not? And this confusion means that when you eventually do get real sugar, your body just thinks, nothing to see here, and you stop processing sugar properly. Well, that's what she thinks the rats did.
So their tongue and their stomach and their brain were all a little bit confused.
Exactly. The tongue and the brain and the stomach, they no longer had any sort of consistent way to predict what was in their stomachs. They knew they'd gotten something sweet, but they didn't know what sweet meant.
But what happens when other research groups try to replicate Susie's studies? Well, one scientist who has tried is...
I don't have that box. Hang on a second, Wendy.
Kieran Bruni. And during our interview, while flipping through a paper, he accidentally smashed his giant commemorative Coke glass.
Yes. So from the days from when I used to drink 2 litres of Coke a day, right?
So Kieran doesn't judge our sugary needs, but these days he's off the Coke or the Diet Coke. He's just a water man. Anyway, he's also a biochemist at the University of Sydney. And he was telling us how he had tried to replicate Susie's findings in rats, and he couldn't.
We have copied their feeding regime and we don't replicate it. And we are at a loss to try and explain why we don't, but we've done the experiment twice now and each time can't get there.
Now, Kieran said that there were some minor differences in the way that he conducted his study, which could have explained the different results. And that's pretty typical of this area. A lot of research groups in this space that are testing if artificial sweeteners are making rats unhealthy are doing slightly different things in their experiments. And there was one team from Brazil that got the same results as Susie's, but others, like Kieran, haven't been able to replicate her results. Conclusion. Some really interesting work in rats shows that when they eat particular artificial sweeteners, they get fatter than other rats chewing on sugar. But the results from different groups are inconsistent. Another thing to consider is, of course, that these results are all in rats. And humans, we're a little bit different to rats. Well, most of us anyway.
Right, you will be reading a Daily Mail piece or a Guardian piece. Artificial sweeteners are going to make you fat and they're going to make you diabetic. And then you go and you have a look and it's a mouse or rat study consuming saccharin.
So, what happens when you look at the studies with people? Do people who consume artificial sweeteners put on weight? Well, when scientists look at large groups of people who already drink diet sodas and follow them over time, the results are mixed. But sometimes they do show that people put on a little bit of weight.
There's this interesting result that pops up from time to time that shows that the individuals who report consuming the most artificial sweetened beverages tend also to have larger BMIs.
BMI, that's body mass index, and a high BMI generally means that you're carrying extra weight considering your height. So, for example, a study published in 2008, which had followed over 3,600 adults for between 7 to 8 years, found that people who drank artificial sweeteners had put on just a little bit more weight over the course of the study when compared to people who didn't drink that stuff. Now, this research shows a correlation, which of course doesn't equal causation. And so, we have to look at another type of study. Here, scientists get regular soda drinkers, so who are drinking the full sugared stuff, and then they get them to switch to the diet drinks and follow them for several weeks to see if they lose weight. And these studies tend to find that switching either does nothing for your weight or it can help you lose a couple of pounds. So, you put all these studies together, and what have you got when it comes to weight gain?
You would not say that there is a comprehensive result one way or the other. What you've got here is a real mix. Sometimes people see a decrease, sometimes people see no difference, and on rare occasions people show an increase.
Ultimately, there's a lot of debate in this field, with some calling artificial sweeteners troubling and others saying the balance of evidence shows that artificial sweeteners could help reduce body weight. So, why so much inconsistency? Well, one reason could be that artificial sweeteners might be having really subtle effects on some people, which could be hard to pick up in big population studies or in studies with not that many people. But another reason for this inconsistency could be that many academics looking into artificial sweeteners are getting funding from the food and beverage industry. One review of almost 400 papers on artificial sweeteners found that 30% of them acknowledged getting money from industry. But Kieran says that you cannot dismiss industry-funded work out of hand.
Sure, it might not be reliable, but you've got to read it and find out, well, whether or not there's actually other good stuff in there. But we've got a lot of data out there that is contributing to the public comment, but it might not necessarily be robust to inform the human comment.
That's a pretty Freudian slip you just did there. Contaminating contributed.
It wasn't. Like, my tongue was firmly in my cheek there, Wendy, but no. Right.
Conclusion. When we look at human studies, it's really hard to know whether artificial sweeteners are making us fat. As best as we can tell, if you're already drinking regular soda and you switch, they might help you lose weight, but they're not going to help you lose a lot of weight. And in the long term, their effects are really unclear. And that's the thing. Artificial sweeteners are not the weight loss silver bullet that you might expect from no-cal, low-cal diet drinks. And this very fact has got researchers wondering why. Why not? After the break, we're digging into a new research field that's coming up with answers. And we're doing an experiment on PJ, our diet soda addict. And things, they're going to get personal.
Would you in a jar for science?
Which branch of science?
Welcome back. So we've just learned that artificial sweeteners probably won't give you cancer and that the studies on whether they'll make you lose weight or gain weight aren't particularly conclusive. But there's a new theory about artificial sweeteners that could explain a lot. It came from a paper by a group from the Weizmann Institute of Science in Israel, and it was published in the very prestigious journal Nature. Its findings created a huge buzz in the scientific community. Since getting published in 2014, it's since been cited more than 400 times in other academic papers. In the academic world, that's kind of like your record going platinum. So the researchers' hypothesis is that artificial sweeteners might not be good for you, But they're not looking at weight or cancer. They're looking at this issue from a whole new angle, the gut. So, to walk you through exactly how this experiment worked, we actually decided to try it on ourselves. Yeah, we're going to do like a dinky version of this experiment. And to start, we enlisted PJ.
I'm fine with that.
And someone he knows pretty well.
I'm in. I'm so in.
Yes. Alex Goldman is PJ's co-host on Reply All. They've known each other for around 7.5 years. And just to set the scene here in regards to how much diet soda we all drink, Alex says he has the occasional diet soda a couple of times a week, but not smashing them every day like PJ. And I actually don't drink diet sodas at all.
So we're like the three little bears.
Exactly.
PJ has too much. You have too little. I'm the baby bear. I'm just right.
So in the real experiment, the researchers were testing whether, 1, drinking artificial sweeteners for a week changed the way that people processed sugar, and 2, whether artificial sweeteners affect the bacteria in their gut. So, to start their experiment, they first had to get a baseline of their subjects' gut bacteria and how good they were at processing sugar. So, about that processing sugar thing, time for a quick science lesson. So basically, if you're a healthy person and you ingest sugars, your body produces insulin, which sends a signal to your cells to pull that sugar from the bloodstream to use it for energy. But if you're diabetic or at risk of becoming diabetic, then your body struggles to get rid of that sugar from the bloodstream. So the sugar keeps on swimming around the bloodstream, and that's not so good for the body for a lot of reasons. But one is that the byproducts of that sugar can build up in tissues like the kidneys and the lens of the eye, and it can cause damage. Okay, so the real experiment went for a week. Day 1 was all about getting a baseline before the subjects were given any artificial sweeteners. So, to find out how well the subjects normally pulled sugar from their blood, they did what's called an oral glucose tolerance test, and it's got a couple of steps. What we did was this. We didn't eat for 8 hours, and then we pricked ourselves with a little needle until blood came out, and then popped that blood onto this little device that tells you how much glucose is in your blood.
It's done.
Okay, no. And then get as much blood as possible. We tested your blood.
Okay.
Then we tested PJ and I, and we got our results. 95.
Is that a good number?
All you really need to know is that we're all in the normal range. And we were actually told not to take these numbers as gospel because we were using this like dinky home test that we just bought at a pharmacy. The real experiment used much more reliable gear. On to the next step of the glucose test. Ingest a lot of sugar. 5 heaping tablespoons mixed in water. Ugh.
Oh, boy.
Done.
Oh.
And then we waited exactly an hour and tested our blood again.
Oh, I am scared of it again. Good.
No, you're not. You'll be fine. Ready? And go.
You would be a good leader of a suicide cult.
Thank you. So PJ was at 140, which meant that he has 140 milligrams of glucose per deciliter of blood. That's on the very upper edge of the normal range. That was the first part of day 1. But then there was another thing.
Okay, so there is one more arm of this study.
Okay.
Depending on how much you want to commit.
In the last few years, the role of the gut microbiome, that is all the bacteria and the other little guys that live in your gut, has become a hot area of research. And as part of this study, the real study, the researchers wondered, could gut bacteria be one of the reasons why artificial sweeteners, even though they're practically 0 calories, aren't really helping people lose weight? And so, to test this out, they tested the gut bacteria in their subjects, which meant, for us,
We need you guys to do a poo.
Yeah.
I'll be doing the poo as well. My own poo. I obviously won't be doing your poo. And then
Everybody has to do their own poo.
Everyone does their own poo. And then you get one of these samples and you swab the poo.
Giving a poo sample was a little bit trickier than we had expected, but we all did it.
I don't want it on my hands. That's so gross. There could be nothing more gross.
For science.
Fine, for science.
We wanted their poo, and my poo, because it's teeming with gut bacteria. Okay, so now we have our baselines, our gut bacteria, and our blood glucose test. Now, the real fun could begin. In the real research paper, the next step was getting people to drink a lot of the artificial sweetener saccharin for 6 days. And that's what Alex and I did. And we had to drink a lot of it, roughly the maximum dose approved by the FDA. 12 of those pink packets every single day. This is 4 packets for breakfast. But for PJ, we had something else in mind.
Uh-huh.
Because PJ drinks so much artificial sweetener, we wondered what would happen to his gut bacteria and his blood sugar levels if he stopped drinking the stuff, like went cold turkey. Essentially, we flipped the real experiment when it came to PJ.
PJ, you stop drinking artificial sweeteners, stop drinking Diet Coke for a week.
Yes.
And then we go back to our normal diets. You can go back to drinking bucket loads of Diet Coke.
And just so you know, this is not a real experiment. Diet Coke has aspartame in it, not saccharin. And this is just like a science demonstration. Just a bit of show and tell. And so for a week, Alex and I swallowed 4 packets of saccharin for lunch, 4 packets for dinner, and 4 packets for breakfast. With, might I add, a very supportive team behind me.
It's disgusting. Breakfast of champions.
In the meantime, PJ was having his own personal struggle.
Not having like my primary gas pedal, it's just like difficult. Extremely difficult.
At the end of the week, we repeated our blood glucose test and then did another poo sample. And then the experiment was over. All that was left was getting our test results back. This is what we've all been waiting for. So, what were we expecting to find? Well, in the real experiment, the researchers found that for around half the people in their study, drinking all that saccharin made it harder for them to process sugar. That is, after doing that glucose tolerance test, the amount of glucose in their blood was higher. And for these people, their gut bacteria also changed over the course of the experiment. But there was also a group of non-responders. And that meant that drinking all of that saccharin didn't affect how they processed sugar, and it didn't affect their gut bacteria. Turned out, when we got all the results, that was me.
Non-responder!
Yep, and Alex Goldman as well. We processed sugar around the same, and when we got our poo samples back, nothing much had changed.
We drank all of this artificial sweetener and then no real effect.
Wow. So you and I pounded a bunch of saccharin, and then after that, it didn't affect me in any meaningful way.
But what happened to PJ? First, let's go through his blood glucose test.
Okay, so you were at 140. Then for a week, you stopped drinking artificial sweeteners.
Worst week of my life.
And now it's at 113.
Whoa. That's crazy.
If our dinky blood testing device is right, that result shows that compared to just a week ago, now there was less glucose in PJ's blood after he drank that big glass of sugary water. But what happened to his gut bacteria? Did that change too, just like it did in the real experiment? To walk us through what happened to PJ's gut bacteria through the course of the week, we called up the very scientist who led the very real experiment that we've sort of been repeating. Yotham Suez is a PhD student from the Weizmann Institute of Science in Israel.
Feels very intimate, you know.
It's okay. Look at gut bacteria for a living.
Now, what happened to PJ's gut bacteria after he drank Diet Coke for years and years and years and years, and then he stopped, going cold turkey for a week?
And what do we see here?
Yotham looked at the results for a while.
You're killing me here.
Turns out, in his gut, a lot happened. Before PJ stopped drinking artificial sweeteners, his gut had a pretty high proportion of this group of bacteria called Firmicutes. And this has been linked to obesity. So, for example, a few studies have found that people suffering from obesity had a higher share of Firmicutes in their microbiome compared to lean subjects. But at the end of the experiment, after just a week of not drinking diet sodas, PJ's Firmicutes rates dropped, while another type of bacteria rose. And Yotham said that gut bacteria tests can vary depending on what time you do a poo and what you've been eating, but still, he was surprised by PJ's results.
If I would have just looked at these results and you tell me these are two different people, I would say that the earlier time points looks like an obese individual, and the other one, the second time point, looks like a metabolically healthy individual.
Whoa! Now, it's not clear at all why certain bacteria, like perhaps Firmicutes, might increase your risk of putting on weight or of not being able to process sugar very well. What we do know is that bacteria in our gut help us break down our food because after we munch on it, they munch on it. And we know that different bacteria love munching on different kinds of food. So it could be that certain kinds of bacteria thrive in the belly of some people who drink artificial sweeteners. And those are the kinds of bacteria that maybe harvest more energy from the food that we eat. And more energy, if you're not using it, could mean more fat.
Hello.
Okay, time to give PJ his results.
Hi. Someone gets the fancy microphone.
Oh, I'll take the fancy microphone.
What have you got in front of you, PJ?
Nothing.
Now, if we find out today that your gut bacteria changed in a significant way after not drinking Coke Zero for a week, what do you think it's going to have any difference on your life?
I think it depends on exactly what that means. I think I'm like already trying to build my rationalization tunnel out of this. So we'll see.
Okay, so
Holy crap.
what we can see is a before and after. So before is
My
PJ.
Firmicutes are through the roof.
And to think I called you a Firma ugly.
Your Firmicutes are through the roof.
That is nuts. It feels like there's like a traitor in my stomach. And I thought it was my friend. Do you know what I mean? The traitor's name is Aspartame. And I'm like, Aspartame, I trusted you. People said things about you. And I was like, I'm not listening to those people. Because we've had a lot of good times together. I never did anything to you.
You've got a look of glee on your face, Alex.
Look, I have a couple times over the 7.5 years that I've known PJ said like, you sure you want to drink all this Diet Coke? Are you sure this is like such a great idea? And PJ's always sort of been like, why don't you shut up and mind your own business?
Yes.
And like,
You could just say I told you so. Like, you don't have to use this many words to say I told you so.
No. I'm trying to give you...
It's like a lot of extra words.
I'm trying to help. I'm trying to say, told you so.
Now, we really need to say here that while Yotham's research has stirred up a lot of interest, he told us that it's really early days yet. And while we haven't told you this, Yotham's real study only had 7 people in it, and a change, a response to artificial sweeteners, was only seen in 4 of the subjects. The rest were like Alex and I, non-responders. But a big reason that his paper got so much buzz was because of this series of experiments he did in mice that showed quite convincingly that artificial sweeteners could change their gut bacteria and could play a role in how they process sugar. Plus, this story of gut bacteria isn't as simple as Firmicutes aren't so cuties. This area is all complicated and new, so while a few studies have found that obesity is linked with Firmicutes, other studies haven't found that. And some work has even found the opposite. That is, that skinny people had more Firmicutes in their gut than another type of bacteria. Kieran Mooney from the University of Sydney, who wasn't involved in Yotham's study, acknowledges all of the caveats, but says
That's a fascinating result.
Do you think it's plausible that by changing the microbiome, artificial sweeteners are making some people fat?
Plausible. Oh, okay, look, you've used the word plausible. I'm going to say yes on that one. Right? So
What if I use the word likely?
I'm not so keen to jump into that boat. I'm in boat plausible. I'm in the HMSS plausible. Okay?
But despite the lack of conclusive research, Kieran personally says he doesn't smash the diet sodas.
Yeah, for my own personal opinion on the artificial sweeteners, I avoid them because there's enough evidence there for me to be wary of them. All right? And when somebody says that they're a better alternative to sugar, then I put a question mark over that.
Conclusion. There is some very interesting work suggesting that artificial sweeteners might be changing some people's gut bacteria. But what this actually means is really unclear. And so you might be thinking, fine, I'll forget the artificial sweeteners and go with the natural stuff, like stevia. That's a sweetener extracted from the leaves of the stevia plant, which is native to South America. And since stevia comes from a plant, maybe it's tempting to think that it's better.
So if I can't go for the artificial sweeteners, I guess I can just go for stevia, right?
Look, the stevia argument's a really interesting one because there are papers out there that suggest consumption of stevia can reduce blood glucose in diabetics. There are papers out there that see no effect of stevia.
Kieran tells us that so far, there just hasn't been a lot of research on the health effects of stevia. In fact, we couldn't find any long-term trials on whether stevia helped people lose weight. What we do know, though, is the fact that stevia is natural doesn't tell us much about whether it's healthy or not. Here's Kieran.
I can't bring to mind a paper I've read where they've used stevia as their sweetener and they've reported harm. But it could simply be that nobody specifically looked for the right thing.
So, when it comes to science versus artificial sweeteners, how do they stack up? 1. Do they cause cancer? Well, there's no strong evidence that artificial sweeteners increase your risk of getting cancers. There was some early studies in rats, but it's never been proven in humans. 2. Do artificial sweeteners make you fat? Well, if artificial sweeteners help you lose weight, which some studies suggest they do, it won't help you lose a lot of weight. And at the same time, there is also research suggesting that consuming artificial sweeteners in the long term might increase your risk of gaining weight. And finally, could artificial sweeteners be doing other things to our body, like changing our gut bacteria and so our ability to process sugar? Well, it's possible, but the research is really too early to tell for sure. So, although the science is far from entirely clear, after PJ's week off diet sodas, did he go back to his old habits? Well, just as we were giving PJ his results, he just had another sip. Okay, it helps you concentrate.
I mean, do you think I'm just going to pour this on the floor? What do you guys want from me?
You could, it's not even giving you pause. That's the weird thing.
No, it's giving me pause. It's like if you tell someone, if it's 19 whatever, and someone's a cigarette smoker, and doctors have been like, cigarettes are fine, and they're smoking a cigarette, and you tell them the cigarettes are bad, they're not going to stuff out that cigarette. It's not how it works.
Are you implying that we're in the 1930s of our understanding of artificial sweeteners?
I don't know. Am I implying? I don't understand where this line of questioning is leading.
And the truth is, we don't know if artificial sweeteners are causing harm. But the way that the industry is contaminating, contributing to the research, is making already complicated science more difficult. And that really doesn't help people when they're trying to make tough choices.
What does this mean for right now?
I mean, I don't know. I honestly don't know. I don't feel super excited about running to the soda machine and buying a Coke Zero. That doesn't feel great. Here's what I'm going to do. I will make myself forget this information. I'll be like, yeah, we looked into it, but we couldn't really figure anything out. You know how science is.
That's science versus artificial sweeteners. Now, before we hit the credits, we really want to tell you about some mistakes that got into last week's nuclear power episode. Thank you for the listeners who picked up on them. We really try to get to the bottom of things and fact check everything on this show, but sometimes some things slip through. First up, we said that the energy that makes nuclear power comes from a chemical reaction. It doesn't. It comes from a nuclear reaction. Chemical reactions involve the electrons in an atom. Nuclear reactions involve the nucleus. Second, we said that the Joker became the Joker after falling into a vat of radioactive waste. This is actually disputed. The Joker definitely fell into a vat of chemicals. But what those chemicals were, that's unclear. Third, a clarification here. We said that the waste that nuclear power produces in the US, which is 2,200 metric tons per year, was like 323 male African elephants. Now, that was a weight comparison. They weigh roughly the same. It wasn't a three-dimensional size comparison. Nuclear waste is much denser than an elephant, and so it takes up much less room. And by the way, if you want to read the most amazing calculation from an academic on how much bigger 323 male African elephants are in 3D space, you've got to sign up to our brand spanking new newsletter. To do that, head to gimletmedia.com/newsletter. And finally, we got a lot of feedback from that episode that listeners really wanted to hear how nuclear power compared to other energy sources like coal and solar and wind. Now, we decided that to do a fair comparison of those energy sources really needed its own episode. It wasn't as simple as just throwing out a number here or there. And so, we're working on that episode for next season. Okay, mea culpa over. Thank you for listening, and thank you for giving us feedback. And remember,
everybody, listen to Science Buses.
Oh, that was so good! That's our last episode for the season, but we'll be back in the fall with new episodes. Although, keep an eye on this feed, because we're going to drop in some extra treats as we're getting ready for the next season. In the meantime, we recommend that you check out Gimlet's newest baby, The Pitch.
I'm Josh Muccio, host of The Pitch, where real entrepreneurs pitch real investors for real money.
How many births are there in the U.S. a year?
So 4 million births.
We open the season with a startup founder taking on prenatal care by trying to replace doctor's visits with technology.
If a doctor were to say to me, listen, I'm going to see you half the time, I would have a problem with that.
Can this entrepreneur talk investors into his plan? Find out on June 14th when you subscribe to The Pitch.
This episode has been produced by Ben Kuebrich, Heather Rogers, Shruti Ravindran, and me. Kaitlyn Sawrey is our senior producer. We're edited by Annie-Rose Strasser, production assistance by Stevie Lane, fact-checking by Michelle Harris, original music and mixing by the amazing Bobby Lord. Extra thanks to Dr. Mary Pat Gallagher, Euromonitor International, and ubiome. And thanks to Leo Rogers. I'm Wendy Zukerman. Back to you soon.